becoming very, very functional as well. The other major option that we have for the enterprise is something definitely worth considering. It's known as an enterprise wireless gateway. Now, this is a device that's very, very specialized. Really, it's focused on providing specialized authentication and connectivity for wireless clients. Enterprise wireless gateways are appropriate for very large-scale wireless LAN environments that provide a magnitude of manageable wireless LAN services, such as rate limiting and quality of service, profile management, and the like. It is important to understand that an enterprise wireless gateway needs to have a very powerful CPU and fast Ethernet interfaces because it may be supporting many of your wireless access points, all of which are going to be sending their traffic to and through the enterprise wireless gateway. Enterprise wireless gateway units usually support a variety of wireless LAN and wireless personal area network technologies, such as your 802.11 standard devices, Bluetooth, home RF, and more. Enterprise wireless gateways also support quite a few of enterprise-wide components that are very useful to the largest of companies. And probably one of the best ones are the authentication technologies that they support. Normally incorporated into every gateway, we will see the VPN and the 802.1x, EAP, and LEAP connectivity, as well as features such as role-based access control, or RBAC. They're really not found in any access point at all. Now, RBAC allows an administrator to assign certain levels of wireless network access to a particular job position in the company. If a particular person that's doing a job is replaced, the new person automatically gains the same network rights as the replaced person simply by being able to log into their machine or to have some sort of a element that binds them to their job role. And this includes different things like protocol filtering, being able to actually have different access points on the network where a particular user is able to connect from, their bandwidth limiting, and all kinds of really neat things that role-based access control can provide. Another component, what's called COS, or class of service, is typically supported in wireless gateways. Here, an administrator can assign different levels of service to a particular user or role. For instance, a guest account on the network may only be able to use 500K on the wireless network, whereas an administrator might be allowed to use a full 2 megabits per second of connectivity. In some cases, we also see things like mobile IP being supported, which allows a user to roam across a layer 3 boundary and be able to get the appropriate IP address and still have routing provided back to their main network, which is pretty cool. And even MAC spoofing prevention, which allows complete session logging as well and does greatly aid in securing your wireless LAN. There's so many more features that can vary significantly between manufacturers that you really want to investigate as much as you can. But one thing to keep in mind is that you need to try to take a manufacturer's class on their enterprise gateways if you can, because some of these features are very, very comprehensive and proprietary and will require that a particular vendor's elements and processes are understood before you actually implement these in an enterprise network. The other thing you want to think about is that these devices can be quite expensive in some cases. So therefore, you might want to consider the number of management and security solutions they provide, whether or not they're going to be worth the expense of the enterprise gateway. To understand the implementation of an enterprise wireless gateway, it's good to have a graphic that can kind of put this in perspective. Enterprise wireless gateways are always installed in the main data path on the wired LAN segment, just past the access points. Now, what you'll notice here is that this particular gateway is actually connected to the wired network itself. It's going to provide all of the services that have been discussed, and it will actually allow the wireless access points to attach to it. Therefore, they associate with the gateway. The gateway, on the other hand, provides all of the services for the wireless network. Now, we think about the way that these are configured. They're pretty much the same as access points. We're going to see telnet or internal HTTP, even secure HTTP with HTTPS. But probably one of the biggest advantages of the enterprise wireless gateway is the consolidation of management. Enterprise wireless gateways actually allow you, by managing the gateway, to manage a very large number of access points or a very large wireless deployment. Basically, what it will do is to consolidate all the wireless access point configurations in one place. Therefore, you're able to manage your entire wireless deployment by using a single point of access. So having just a few enterprise wireless gateways can really consolidate the amount of management that has to take place. With enterprise wireless gateways, their firmware are normally updated using web or TFTP in very much the same fashion as most of your switches and routers are in today's market. Configuration backups can often be automated so that the administrator won't have to spend any additional management time backing up or recovering from lost configuration files. Enterprise wireless gateways are mostly manufactured as a rack-mountable unit, either a 1U or a 2U device that can fit right into your existing data center design and can really be used effectively in a large-scale wireless deployment. Whether your enterprise network begins in San Jose, California and goes all the way across the world, or it just is contained into one small area, being able to take advantage of some of these other wireless devices can really help you to maximize your investment. From a wireless bridge or workgroup bridge all the way up to an enterprise wireless gateway, you'll be able to accommodate the appropriate feature set, security, or any other option which is necessary to make your wireless LAN the best it can be. We can talk radio frequency all day long, and you know what? It's not going to do us a bit of good, not without an antenna. Antennas are the magic behind what makes radio frequency really function. And if you can properly understand antennas and how all of the different types work, and then be able to tune your antenna deployment to fit your wireless need, you can have a perfectly operational and utmost performing wireless network. Up to now, our discussions on RF theory and some of the major categories of wireless LAN devices that an administrator might use on a daily basis are a great foundation, but honestly, they're of little value to you without a solid working knowledge of antennas, which are the devices that actually send and receive all of the radio frequency signals. Of all of the concepts with antennas that you'll probably want to master, the most important is going to be proper antenna selection and placement. Antennas, of course, are used to increase the range of wireless LAN systems, but honestly, proper antenna selection can also enhance the security of your wireless LAN. A properly chosen and properly positioned antenna can reduce the overall signal leakage out of your workspace and make signal interception extremely difficult. So if done correctly, this is an excellent thing to do in your wireless network design. Now, there are going to be three general categories into which all wireless LAN antennas fall into: omnidirectional, semi-directional, and highly directional. Each of the antenna choices that we make are going to be based upon one of these three. Each category that we find is going to have multiple types of antennas, each having different radio frequency characteristics and different appropriate uses. As the gain of the antenna goes up, the coverage area will narrow, so that high-gain antennas offer longer coverage areas than low-gain antennas at the same input power level. There are also many different types of antenna mounts that you're going to have to get used to, and each one is suited to fit a particular need. The first type of antenna that we have, and the most common wireless LAN antenna, is what's known as the dipole antenna. Simple to design, the dipole antenna is standard equipment on most of your access points. The dipole antenna is actually an omnidirectional antenna because it radiates its energy equally in all directions around its axis. Directional antennas concentrate their energy into a cone known as a beam. The dipole has a radiating element just 1 inch long that performs an equivalent function to the rabbit ears antennas that you would find on television sets. The dipole antenna used with wireless LANs are much smaller because wireless LAN frequencies are in the 2.4 gigahertz microwave spectrum instead of the 100 megahertz TV spectrum. As the frequency gets higher, the wavelength and the antennas become smaller overall. Now, probably one of the most important concepts of the dipole antenna itself is what's known as the dipole donut. The dipole's radiant energy is concentrated into a region that looks just like a donut, with the dipole vertically through the whole of the donut. The signals themselves from an omnidirectional antenna radiate in a 360-degree horizontal beam. If an antenna radiates in all directions equally, forming a sphere, it's called an isotropic radiator. The sun is an excellent example of an isotropic radiator. Now, we cannot make an isotropic radiator, which is the theoretical reference for antennas, but rather, practical antennas all have some type of gain over that of an isotropic radiator. The higher the gain, the more we horizontally squeeze our donut until it starts